Hello, everyone. Good evening. Good evening, everyone. Hello, everyone. Okay, I hope that the people that are late are going to be so mad about themselves when you tell them how fun this night was. Thanks, Mike, for the enthusiasm. As you know, it's such an amazing amount of work from everyone in the committee and the organizers. Thanks for Mike, Kate, Braden, Chris, Eamon, and all the others who've put countless hours into preparing this conference. Having everyone here, yes, thank you. Big round of applause for everyone. We're already past halfway point of our conference. It's been so fun to meet all and each and every one of you, and I hope you're going to enjoy the rest of the conference also. Before we start, some rules about the lightning talks. If you've never saw lightning talks, there are 5-minute-ish talks. I can give you a little wiggle room of a couple of seconds before I kick you out of the stage. For the speakers, there is a designated speaker microphone. This is my microphone, so don't touch this one. I have a clicker. You have to click down to make the slides go forward, but I'll be there to help you if something happens. And what I'd like to do before starting the lightning talks is to talk to you a little bit and show you something that we should do is that last year's lightning talk, if you were there, it was a morning session, and I didn't have a lot of time to show to help learn a little bit about ourselves. So what I did is prepare some quiz last year. And we only had time to do 3 questions. So who wants to be the first one to start for the first questions? It's simple. There's money on the board, there's questions, and simple answers. No, Mike, sorry, you cannot do this. Because if you would know me enough, I hate doing the same thing twice. I'm a programmer. I program things together. So no, we're not going to be doing this quiz today. If you want to do that quiz, create a time machine, go back last year's lightning talk and ask me the question. What could I do? What could I do to show you my love of this conference? Well, I proposed a talk for this conference and I wasn't accepted. And now that you're all here looking at me and listening to me, do you think that I could do my 1-hour talk into a 5-minute talk and show you how to not do a lightning talk, because it would be a very, very fast lightning talk where I will talk very, very quickly to do all of my slides in only a 5-minute time slot? No, Mike, sorry, this is not what I'm gonna do. What I'm really gonna do, is really show you the love that I have for this conference. Because I see a lot of new faces, but I see also a lot of familiar faces. In 2022, it was the first edition of CppNorth. Who was here for the first edition of CppNorth? I see a couple of hands raised. Yay! Good. But most of you weren't there, so I'll show you what you were missing from this conference. It started out as a CPP Toronto meetup group, and then grew out. Yes, this is the Wayback Machine first ever CppNorth website that was started. See my notes? Yay! At the very first CppNorth 2022, we had the very exceptional Kate Gregory on the very first talk, very first keynote, giving us insights about how we all feel as a programmer after a 5-hour debugging session, and then finally finding that the problem was just a typo.
I am so stupid. Why is this my job? Who gave me a job I'm this bad at?
Yep, thanks, Kate. I think we can all relate. But by the end of her talk, she just showed us how much we love doing what we do.
What's the most important advice for having a good life is, do you enjoy it? Do you like turning the skin on your fingertips into working software?
Yeah, I do. That's what I do for a living, and I absolutely love every minute of it. We also had some weird guy. Do you know a guy named Tony Van Eerde? He came there the first year, and he compared his whole talk to the Star Wars saga. Yeah, he said that his whole talk is exactly like the Star Wars saga.
Good job.
Do you see the link?
Right? Yeah. Very subtle. It was the 4 dots. The 4 dots give it away. All right.
That's the only thing that's similar to the Star Wars saga. The Ford Austin is a presentation. I see yesterday he was quoting also Star Wars, so it's a nice reminder. Who do we also have? Oh yeah, we also had Fatima. Thanks for that laugh. Of course, we had the legend. We had Sean Perrin there with a very, very mindful thought about safe operation.
An operation is safe if it cannot lead to undefined behavior.
Absolutely, an operation is safe if it cannot lead to undefined behavior. You agree? Yeah, but I'm sorry, Sean, I'm gonna prove you wrong in a second, because I did a lightning talk this year, that first year was my very first public talk about programming, and I did a safe operation that led to undefined behavior.
So you just start a timer and just...
Yeah. Starting the timer is safe, but not hitting a microphone. Undefined behavior. You never know what's gonna happen. Maybe I started a black hole in some galaxy somewhere. You never know. Thanks, Fatima. And then came 2023, a whole year passed. It was so very rapidly reorganized. Thanks, Mike. And we had a second edition of CppNorth 2023. Andreas Weiss was there from Germany, I think, and thank you. And he summarizes the whole conference in one sentence.
There was a talk by the one and only Kate Gregory.
Of course, there was a talk by the one and only Kate Gregory. And there was Connor that was there to show us what's the goal of the conference.
The goal is to eat as much sushi as possible.
Wait, really? Is that it? Oh yeah, I think Kate was on his side.
This is what sets beginners apart from more seasoned developers.
Oh yeah, what was that goal again?
But the goal is to eat as much sushi as possible.
Oh yeah, okay, only experts can eat mountains of sushis, and this is not prepared. I didn't know there was sushi today for that dinner there. That's super awesome. We had our friend Miro that was there, teaching us how to intercept all memory calls to create your own allocator and then sanitize your memory.
In malloc, new, mmap, virtual alloc, virtual free, heap alloc, heap.
All of them. It's an hour-long talk about that. It was super cool. We also had Ben Dean. Please help me, Ben Dean, show my audience how fun it was for 2023.
This was a messy time.
Oh yeah, maybe. But it was fun. There was one of the presenters that found his true love in life.
I love ranges.
Yep. And it's been a love affair since the beginning of ranges. I absolutely love them. Oh, and by the time we were in the lightning talks, we had also Miro showing us, like, how do we feel as a newcomer to programming and how we feel learning the learning curve.
Eventually you get there, and then you have this rapid rise in skill, right? You're getting fast and productive. And then eventually you plateau as you become more experienced, you become this expert, right? And there's only a few things that really are left to master. Is what I would say if this wasn't C++, because this is only your first 10 years.
Yeah, sorry. Oh, and then, unfortunately, we had to leave, but come back for the 2024 edition. Yay! That was awesome also. There were a lot of different speakers from all over the world. It was our most international edition yet. There was Alex that sets the basics for sets the ground for the rest of the conference.
Know your CPU.
Just know your CPU. Just ask him a question. Do you know the name of your CPU? Has anyone just asked him his name? Just relate to your CPU. It's important. We also had Paul Williams from Bloomberg that came all the way from England to ask us some very important questions.
How many allocations do you think happen when I run this program?
And some good answers from...
Guesses?
More than one.
More than one. Great answer.
We also had the first representative from CPP Africa coming to Canada to help us spark our intellectual curiosity and not take everything for granted and ask some good questions.
And I said, okay, so why should I type push? Because I know computers don't understand English.
Yeah, why push? And the guy that invented that probably not even speak English correctly. It should have been like download and upload. Why should we push and pull and get... Anyway. Oh yeah, of course, we had Kate Gregory.
You know, they say, like, getting old's not so bad when you consider the alternative.
So we all have the chance to learn more and more and more because no one's dead here. Yay. So you can have the opportunity to continue to learn. Great for you. I maybe die after, that's not a problem. I missed that one. And someone just cheated on his true love and started loving other types of code.
A coroutine in a module. Yes, of course, in a module. I don't do anything else.
Yep. So now I'm a trouble. Now I love modules, coroutines, and maybe ranges are not so back there, but yeah, absolutely. If you've never tried modules and never tried coroutines, please do. They're great. They're great. Oh. Anyone knows Eric Wassel? He's the inventor, creator, maintainer, mastermind of Advent of Code, which releases every year. And he was there to tell us about, like, how do you manage server load?
And then the graph did this. The technical term for this curve is, oh no!
Yeah, that was the first night that he set it up, his system, thinking that there would be only like 50 people using WISPipe, and then, whoo! Thank you. Oh, yeah, absolutely. My friend Myra was there showing us how a string compression works like we all do with abbreviations. We say strcmp for string compare, and he said, so bad. The wolf swallowed a handful of grains. But there's more.
And now comes an actual choking hazard.
Yay! I've learned Czech now. Super much. Yeah, it's a whole paragraph of text. You should watch that. Oh, and what can I say? We had the most farthest applicant from Australia that came us to show how to compose music at compile time on your computer.
There we go.
Only if you can type.
And if I can type.
Yeah. No.
Oh my goodness. Yes, that is the most elaborate Rickroll today.
But it was already over. And we're already here. CppNorth 2025. We're going to have a lot of fun tonight. A lot of very interesting speakers with a lot of interesting subjects. I think we have 15 speakers tonight presenting to you. Some of them, it's the first time that they're going to be speaking. Some of them are volunteers that agreed because I pressured them, probably not too much, I hope, to do lightning talk. First up is Ed Beroset, because he didn't have a slide, so this is your slide. Thank you, Ed.
All right. And because it's a lightning talk, I am setting a timer just to make sure. So, all right, ready, set, go. All right, as you heard, I'm Ed Beroset. I am here to tell you about management and why, if you are not currently a manager, why you might want to think about it anyway. So during the course of my 40+ years in tech industry, I have been a manager, I have been an individual contributor. Actually, currently, I am an individual contributor. So the thing that I've noticed is that there is an easy, straightforward management path that you probably already know about. At some point in your career, though, whether you have it in mind or not, you are likely to be asked, hey, can you lead this team? Can you become a manager of this organization, sub-department, or whatever it happens to be? Me, I was stupid and said yes, way prematurely. It was a dysfunctional team, which I kind of already knew in the first place. There was a person there who was very resentful that I was getting the job and not him, so it didn't start out very nicely. Could have been better. But with that, you might have thought I would say, well, to heck with this, I'm never doing that again. But I've been in and out of managerial positions throughout my career. So that brings me to point number one that you won't often hear, is that no choice you make, or very few choices you make in your career, are irreversible. So I was asked, do you have any slides? And the answer is actually, yes, I have one, but it's in your mind. So if you've gone through this little park back here, there's a slide that the kids like to go up and slide down. And if you think about the analogy, when the kids say, wee, are they doing that on the climb up the ladder? Probably not, right? It's the way down. So think about that. Think about that. Now, so the other obvious thing there is that on the way up, you're doing the thing, you're earning more money, you're gathering more responsibility. Suddenly you're a manager, you're responsible for other people. What about that way down? That doesn't sound as fun as you depict there. Okay, that's fair. But, you know, sometimes I get nostalgic for the time where I just worked on code. And so you may also decide at some point in time, enough of this. I'm tired of the responsibility, the being responsible for other people. I didn't get into this because I like to manage other people. I got into this because I like to play with code. I like to make computers go and do tricks. And that's perfectly valid. And you definitely, throughout your career, no matter what you do, pay attention to what you actually enjoy. And as we heard a clip from Kate saying exactly that. That's very solid advice. So I would say that you can make a change at any point in your career. You have to be a bit judicious as to where, pick your timing. One of the questions I've been asked before is, so when you go and into management, you often get a pay raise and a title inflation of some kind. True. What about that wee on the way down? I can tell you with an N of 1, so just my career, I've made that transition a number of times. I've never had to take a pay cut. So food for thought. It doesn't necessarily follow. And part of that is because you have more experience, you're better known in the organization, or in some cases, I just changed to a different company, a different organization. It's worth thinking about. The other thing I'll mention that's probably worth saying is that it's pretty easy to go from a managerial position to a single individual contributor position, kind of anywhere in your career. It's a little bit harder if you haven't had any management experience. If you're mid-career and you decide, hey, maybe now's the time, it's a little bit harder if you haven't any management experience. But with that said, if you're a team lead, that counts. So this isn't to convince anybody to choose the path of management and enlightenment, but it's really just an exhortation for you to think about it. It doesn't need to be forever. It's not as scary as you might think. If I can do it, I'm sure you can do it. And it has some rewards that are not always tangible. It's not just additional money, additional responsibility, but actually mentoring people and seeing them come along is really great. And if you do it right, you can hand your job off to somebody else. Thank you.
Nice. Timing was right. Awad, you're next. It's not terrifying. We're all friends. We're all friends. Picture you at your home. I think it's the PDF.
Yes. I was going to send you a PowerPoint, but then I remembered I use a MacBook, so I don't get such luxury.
Go ahead. Nice. The stage is yours.
Thank you. Shout out to Clang D. This talk was about to be about them, and then the Clang D install on my computer broke entirely this morning. So it's not their fault, it's Apple's fault, but let's not start on that. So triple buffering and channels.
They're not seeing this slide.
Oh, they're not?
No, they're still seeing the presentation because it's still presenting. Sorry.
It's okay. I've dealt with a lot of technical issues today and the past 2 weeks. Yeah. I got stuck on that 5-hour bug because of a typo. I forgot the number 2, and the GPU thought I was passing it an array of floats when they were float 2s. Anyway, so triple buffering and channels. So who am I? I'm Awab. You can read more details. The important stuff is I graduated in 27. Please hire me. Anyways, all right. So far it's been a pretty light, lightning talk session. Hopefully I picked something easy for the drowsy crowd. Oh no. Oh dear. Well, let's see how hard I can shoot myself in the foot. So multi-threading is really hard, right? Let's assume, you have this person over here. His name's Evan, no relation to the actual Evan, of course. And let's say he's a really good artist, like a really, really good artist. Like, if you need art done, you have to go there. There's no other choice. All right, and then, of course, since he's an artist, all artists, of course, have to deal with evil and intimidating customers who think that they're right. So the customer is like, oh, Evan, you got to do this. You need to compute this. You need to render this. And if you don't, I will be very mad at you. And the customer keeps sending these large chunks of data, huge. And poor Evan is just so tired. Evan has become the render thread. Please pay your respects now. So anyways, you have this compute thread, and the compute thread is out there computing things. Maybe it's computing the new location of some water or some particles. And it's just shoving data into the void and hoping that the render thread will print it out to the screen. So you have this very interesting problem where the render thread cannot be blocked because otherwise your application gets unresponsive. But your compute thread can also ideally not be blocked. So the render thread always wants fresh new data, but the compute thread always wants a place to put this fresh new data. And this data is big, like 80,000 rows in an array or something. So we need to reuse some memory. Well, this is the idea that I came up with, not so independently. This is a triple buffer system. So the idea is let's keep 3 buffers. If we keep 1, that's not enough. Someone's going to be blocked. If we keep 2, well, it'll work for a bit, but then when the compute thread wants to swap the double buffer, it can't because the render thread has it. So now we have 3. We have a render, a ready, and a scratch. The compute thread can just write to the scratch buffer, and the render thread can just read from the render buffer. And when the scratch thread is done computing, it just swaps scratch and ready. And importantly, it can do this without affecting render's lovely render buffer. Similarly, the render thread can swap ready and render. So it can always get that new fresh frame without affecting the compute thread, which is writing off in the scratch buffer. We have freedom. Isn't that lovely? Well, the problem is I showed this to my project partner, and he looked at me, and he said that I wasn't allowed to write this code. He said it was too ugly. So you gotta wrap it in some nice abstraction for the Zoomers nowadays, So how do we implement this? Well, the answer is this is where channels really shine. So what is a channel? A channel is this black box. And the idea is instead of these threads talking to each other, they only see the channel itself. Actually, they only see half of the channel. So the compute thread only sees the sender half, and the render thread only sees the receiver half. So as far as the compute thread is concerned, it just calls send, and as far as the render thread is concerned, it just calls receive. They never actually realize that there's this weird triple buffer symphony happening in between them. So, you can imagine, just imagine these pink little boxes are frames or whatever. And, the compute thread has computed this lovely frame of a cat eating some grapes. And the render thread just grabs it, begins rendering it out to the screen. The compute thread is gone. It's doing other stuff. It doesn't even care. And when it's done rendering this lovely dog image, it goes and grabs another buffer, and it keeps writing. And maybe it even finishes and even overrides that one, which is fine because, the render thread doesn't care if it gets every update. It just cares that it gets the freshest one and that it could always get one. Then the render thread just comes in and grabs it. So you can really see how it's genuinely almost like the compute thread is just passing data along it does not care where it's going, where it's coming from, anything. And the render thread is genuinely just grabbing that data. It doesn't care where it's coming from, where it's going, or anything at all. And what we've done is we have effectively abstracted away this communication interface. And here's some example usage. Here's some code. Code on slides is ugly. It's not like you'll read this it's fine, it's fine. This lock-free implementation is not right. Don't look at it, don't look at it. It's okay. Oh God, why is there more? Please go away. All right, yeah. So channels are really cool, and this is just like scratching the surface in a quick lightning talk. But the idea is that I want you to think about is there is so much you can do when you no longer have to care about the communication interface. This channel could be a queue. It could be a double buffer, a triple buffer. It could be any sort of weird latency insensitive thing that needs to exist. And your threads only need to care about how to get data and how to give it. Here is, Rust's implementation for channel if maybe you're interested in seeing someone who actually knows how to program. Maybe we'll get channels in the standard library. I honestly don't think so. They are a bit specialized, but they really made my week a few weeks ago, and I just wanted to share that with all of you. I believe that's it. Thank you.
Thanks, Awab. Please stay as long as you can to see the rest of the presentation. He needed to go up earlier, so that's why he was the first one. Who wants to be the second one? It's written over here. Sarthak, you're the next one. Oh, you have your own time.
Is that going to be my mic?
Oh, this is going to be your mic.
All right.
Yep. Thank you.
Start the timer. Hey, it's me again. I saw the other 12 speakers a bit worried about the 2 solid talks we had, so I thought I'd ground everyone, set a base so that everyone else is not worried after me. Talk about the boring stuff in C++23. So yeah, I'm going to be talking about deducing this and stood for like. Both of them were introduced in C++23. Bit about me, I'm Sarthak. I'm a tech lead at a high-frequency options market-making firm in Chicago. You can read the rest in the slide. So yeah, let's get right into it. Imagine you're writing a class which has a container. Just for an example, I have this chessboard class. It has an 8x8 chessboard, and it's a linear array. And being the good developer you are, I know there are some eyebrows being raised probably right now that the board container should be private. It will be. I just missed it in this slide. But yeah, being the good developer you are, you've provided an abstraction to the client and an at method, which returns a reference to the client passes your row and column, and it returns a reference to the element. That's great. Except when the client now writes a print board method, just needs to print the board, and there's no reason that it should be a non-const reference. So the client writes a very good function, takes in a const reference, and now this fails because the add method is non-const. So you decide to add a const overload. That's great. Accesses the board in a const manner, returns a const reference. That's great. But now there's some oddity here. You can see that you're now starting to repeat stuff. You're calling the exact same function board.add in 2 different methods, and this could be way more complicated. So it doesn't look that great. And this is exactly what deducing this addresses. But before deducing this, what you could do is you could have a static auto ref add function. What this would do is that the first parameter would be an auto reference. The second all the rest of the parameters would be the same. And each of your add function, the const and the non-const overload, would simply pass the object type. And with the auto type deduction rules, it would either be deduced to a const ref or a non-const ref, depending upon what the caller object is. So you could not repeat yourself even before C++23. But deducing this makes it much simpler. Oops, bit of a, yeah, okay. So if you ignore the second half of the slide, the first half is basically what deducing this is. It simplifies the implementation of the static add method that I had previously. With deducing this, now you can have a return type as an autoref. The first parameter always has to be like a this autoref, like the templated ref with the this keyword, which signifies that deducing this. And then there's going to be rest of the parameters. So now, if the client calls this with a const object, then it's going to return a const ref. If the client calls it with a non-const object, it's going to return a non-const ref. That's great. Except if the client now tries to do std move chessboard.add00, it returns an error. But that's pretty simple to fix. In this slide, I just have, instead of the two overloads that I had in the previous slides, an L-value non-const overload, an L-value const overload. I have overloads for the R values as well. So basically, instead of, like in most of the classes like std optional, instead of repeating just twice, it's actually repeating the same code 4 times before C++ 23. And now, with deducing this, this is all you need to do. You can have a forwarding reference of like the return type as an auto anan, which is a forwarding reference. The first parameter would be this auto anan for forwarding reference, and again, this keyword signifies the deducing this usage, and that's all. You're done. No need for the 4 overrides. There is one drawback in this slide, though, which is the usage of std forward, which std forward like addresses. But I think I'm out of time. And that's always the case with lightning talks, so I'm going to skip that. All right. I think I can do it in 30 seconds. So if you use the function as at the very bottom, std move chessboard.add00, with the current deducing this implementation, it forwards the object type and then calls the .board.add method with the forwarded object type. So if you have a R value reference of the object, it's going to call, it's going to forward it as an R value reference and then call the .add method. But what you want to do is that the return type should be the same as the object passed, which is the R value reference. And forward like is meant for those purposes. But I think it's probably not doing justice to it in 30 seconds. So I'll send the slides. Feel free to play around with it on Godbolt. And that's all. Thank you.
Thank you. Who's next? I think it's Tony. Come on down, Tony. I do care about performance. Show me. Your mic. If you need the clicker or the arrows there, it's the down arrow.
Is it this one? The way?
Yep.
Okay. Hi, I'm Tony. So I do data analysis for genetics. And so I'm telling you why I care about performance, not necessarily why you should. So it all started when I was doing my PhD in genetics, and I got some data, and I wanted to analyze the data, and I was asking around, and they told me, if you need statistics, it's not significant. So I learned statistics then. Shortly afterwards, the genomic revolution happened in genetics, so we had a ton of more data where that was a good move because now we really could not do without statistics. But it became computationally intensive, right? So I was looking around. We were basically running out of compute power faster than, because the data were growing faster than computer power was growing. So I was asking around, how do you analyze that data more efficiently? And my statistician friends told me, buy a better computer. So basically, the talk is about why that is not a satisfactory answer for me. First of all, you can't tell your funding agency this, but it's no fun to just go buy a better computer. It's a lot more fun to come up with a way to analyze your data so you can do it on your laptop, and it's really nice. But a serious answer too is not everybody can buy a better computer. And this, this one? There it is. So these people. So I do a lot of agricultural related genetics, and this is a plug. If you want to change the world and get a biggest delta possible for a unit amount of money spent, medicine ain't it. It's agriculture, and specifically agriculture in non-rich world, right? And a big thing, especially with climate change, is improving crops, well, in animals too, but I happen to work in crops, where we need to quickly select better varieties that are adapted to the climate that we haven't seen before. A lot of these places haven't seen before. So, and the way it works, right, every year, the breeders, so not these people are the farmers, sorry, thanks. But behind them stand local breeders who do the crop improvement and then produce the seeds that these people then use, right? And so the breeders have to basically put out a bunch of seeds on the field every year, collect the data, make their selections, put the things back in the field. Now with the genetic revolution, we can actually speed up that cycle because they don't need to necessarily select based on what the plant looks like. They can do genotyping, which is a lot cheaper, and also they can do some cycles in the greenhouse where they don't know what the actual field relevant phenotype is, but they can genotype their things, predict the phenotype, and this involves sophisticated models, and we want them to use the most sophisticated models they can get their hands on, but they cannot buy a better computer, and they cannot use Amazon Web Services because they don't have a good internet connection. So they have to be able to do analysis in a really fast turnaround time. They have like maybe a week before the harvest and putting the seeds back into their greenhouse if they want to upcycle. So they have a restricted amount of time, and that's why, for me, it's very important to generate code that can be run by these people on their underpowered computers really quickly, get the data they need, and that really literally saves people's lives. So that's it for me. Thank you.
That was great. I love that. Surprises talk. I love that. Next up, no, it's not a laptop swap. This is going to be, oh, no, it's not a laptop swap anymore. Evan, it's your time. Yay. Evan? I don't know. Evan? And you'll be able to click on the link to show up the information.
Sure. Okay, do I just stand here?
Yep.
Okay.
You have the microphone over there. This is
I
the
didn't
microphone.
even see that.
Yep.
Wow. Okay, I'm so loud now. All right, hi folks. I'm Evan, and I'm here to talk about implicit conversion sequences. Now, maybe you don't know what an implicit conversion sequence is, and let me enlighten you. So if you declare a variable of a certain data type T, and you want to initialize it with an expression of type S, you need to convert that expression of type S into an expression of type T. And C++ has very rigorous and particular rules about how that can happen through sequences of these conversions. So to get you well acquainted with these, here's a piece of code where you have a function that takes a parameter of type rValue reference to array of 6 const char, and we're passing it the string literal hello, which is 6 long, remember the null character. So is this L form? Does it compile? Raise your hand if you think it compiles. You're wrong, it doesn't compile. String literals are L values. They're the only literal that's an L value. Okay, here's another one. Foo is a function that takes a parameter p. It's an L value reference to pointer to int, and we're passing it an array of length 3. Surely this compiles. Raise your hand if you think it compiles. It does not compile. The standard conversion sequence that's followed here is an array to pointer conversion, which turns the L value of type int3 into a PR value of type int star, and you can't bind a PR value to an L value reference, so it's over. One last one for the fans. Suppose you have a function foo that takes a parameter of type pointer to array with unknown bound of int, and you're passing it a pointer to array with size 5 of int. Now the only thing that changes in this type is that you're replacing that 5 with an unknown bound, so you know, one would hope that this is a relaxation that works. And I won't even ask the question this time, it's ill-formed. If using GCC, it will compile it, but GCC is wrong, you should use Clang. And the standard conversion sequence that's followed here is an L value to R value conversion. So it takes it to, you know, I don't even know how you pronounce this type, but it turns into a PR value. And then, you know, you have to do this qualification conversion thing, and that fails. And oh, that's what that looks like. Wow. So the qualification combined type T3 doesn't end up equaling T2 because a const showed up there somehow. And, you know, so this is kind of inscrutable, but one thing I'm doing is I'm at least showing you the reasoning. Clang will never show you the reasoning. It will not show you this table. And if you did a little bit of standard reading, you could assign some, you know, semantic meaning to this table, and maybe it could be a little bit helpful. But alas, I cannot make tables like this for every possible type. I have finite time. And it's hard to make these tables, you know. It's like doing linear algebra. You're going to screw it up. And you know, these rules for how these conversions, even the qualification conversion, any of them are done, are spread across like 20 sections of standard. They don't all refer to each other, so you can't find them all. There are a lot of them. And I mean, we're also enterprising folks. We like making the computers do things for us. So you think what I'm thinking. That's right. We're going to implement overload resolution ourselves. So here, let me show it to you. Allow. No! I pressed the wrong, okay. I misread, that's fine. Okay. All right, it's fine. Okay, so I don't have a name for this yet, but here we go. We can construct a type. So let me construct the one from before. I think it was pointer to array with size n, say 5 of them, target type, array with unknown length of, and let's convert. Here we go. And here's our table. And let's see where this comes from. Okay. Now I think I'm actually missing a pointer to, so let me add that. And you'll see a scroll down, and okay, actually it fails. And let's see that qualification conversion. What went wrong here? Okay. So here's where that extra const came from. It's because there's a difference between the array of 5 and array of unknown bound of part. And if you have something like that, it means that all of the consts that come before it, except for the first one, you know, all those need to have an extra const unioned in with them. And I think I'm almost at time, but you know, you can get kind of elaborate with this. Oh wow, the browser really doesn't like that. And you can do this with functions too. So if I may show a pointer conversion or to function type, and let's say that's good, not no except convert, and it works. I don't have a point with this, and it only supports standard conversions so far. I haven't gotten to user-defined conversions yet and reference binding, but I will get there. I've only had a week to work on this. And it's available at consteval.ca/ICS if you want to try and break it for me. Thank you. Also, send me an email if you want to hire me.
You have the best domain name ever. Thank you, thank you. Next up, I think, if I remember correctly, my pacing is me. Yay! No, just I wanted to split a bit between the PowerPoints, the PDFs, and all of that. And I have a little story to tell you. Maybe this way. Okay. Yeah. Great. Still works. So yeah, this is my mini lightning talk. It's not really a lightning talk. It's lightning story. Yeah, the name is, what is a hero? Yeah, because what is a hero? If you remember correctly, I think it was almost a year ago, Boeing tried to send some people on the International Space Station, and they had some problems. They tried to, with their new Boeing Starliner ship, it's called, 2 astronauts went on the Boeing ship. He's called Butch Wilmore, on the right there. That's not necessarily a hero, we'll see. He was flown onto the space on a new starship that was never flown before. So there could have been millions of things going wrong, and some people needed to be aware of those consequences. So as they flew towards the space station, everything went fine for the first burn-off, and they went into space, and they need to align correctly to the space station. Once they were like 200 meters from the space station, one thruster started to fail. Thrusters help them with the yaw pitch roll control of a starliner, and they can fail because they have fail safes and redundancies. So after the first thruster failed, everything went fine. Okay, the control started to be a little more sluggish. Then the second thruster failed, and then he's saying, okay, I know my math, my algebra, that this one failed over there, this one failed over there. I think I still can maneuver a little bit. But if more than 2 thrusters out of 28 fail, the mission controls say, stop the mission, you have to come back to Earth. But you're 200 meters from the space station. You're at the worst spot to say, okay, abort mission, we're going back to Earth without my thrusters, without knowing where am I going to be able to land. And then they lost the 3rd thruster. And then they lost the 4th thruster, a couple of meters in front of the space station. That started to be really concerning for the astronauts, for NASA, for Boeing, for everyone. And what happened? I need to read this quote from Butch Wilmore that explains to you what is a hero. Thankfully, these folks are heroes. And please print this. This is a news article. What do heroes look like? Well, heroes put on their tank on, and then they run into a fiery building and pull people out of it. That's a hero. But heroes also sit in their cubicle for decades, studying their systems and knowing their systems front and back. And when there's no time to assess a situation and go talk to people and ask, what do you think? They know their system, and they know them so well, they'll come up with a plan on the fly. And that is a hero. And there are several of them in mission control. And I'm sure that there are several of them in this room right now. This is what the spaceship looked like as it finally could dock to the space station with 4 thrusters working, because the solution was to ask your expert, your NASA astronaut, to let go of the controls. We're going to reboot the system. You're meters away from the space station, and they actually tell him, remove your hands from the control, we'll reboot everything, thrusters are going to be fine. And it worked. And they could autonomously dock to the space station without any more problems, and then the rest is history. Great. So now after this little break, we continue our super fun lightning talks, which was okay, that's good. Next one, I finished the PPTs. I think it's already opened. It's David. David, come on down. This is your microphone, and this is your stage.
So when Pier-Antoine said it was crazy to cram an hour-long talk into a lightning talk, I took that as a challenge. Because I gave an hour-long presentation at CppCon last year that was a complete and thorough introduction to C++ templates. I thought you might like to see that talk here. But I only have 5 minutes, so I'll have to go through this very fast. Pay attention. The basics. The template keyword followed by template parameters. Lots of things can be templates. Define your templates in header files. An example of a class template. The keyword template, template parameters, use template parameters as types. You can use the keyword type name instead of class. And type alias template example, variable template example. How to define a template parameter. A type template parameter represents a type. A non-type template parameter represents a compile time value. A template parameter represents a template. Template parameter names are optional. Template parameters can have default values. Template parameters can be variadic. Non-type template parameter example, std array. It has a type template parameter. It has a non-type template parameter of type size t. Class templates can have member functions. Define them in the class because defining them outside the class is complicated. To use a template, it's a template name followed by template arguments. Example, where arguments are all types. Sometimes template arguments can be left out. Substitution versus instantiation. Substitution checks the correctness of template arguments. Instantiation checks the full definition. For classes, substitution results in an incomplete type. For functions, substitution happens during overload resolution. For classes, instantiation results in a complete type. Example of a class template. Instantiate it with int and data. Behaves as if this were in the source code. Instantiate it with array of int and data. Equivalent to this, the data member is fine, the parameter is fine, but the member function returns an array. That's a compilation error. Instantiation of a function template gives a complete function definition. Example of a function template instantiated with double. Substitution failure is not an error. Instantiation failure is an error. Using class templates. Each instantiation is a separate type. Different instantiations of the same template can't be implicitly converted, even if the arguments are closely related types. Std array, again, is an example of a non-type template parameter. It can be instantiated with a type and a compile time value. Instantiating with 2 types is an error. Instantiating with 2 constants is an error. Class template C has a template parameter. If we instantiate C with a type, the compiler complains. Instantiating C with template A is fine. Instantiating C with B won't work. B is the wrong kind of template parameter. The compiler complains. Using function templates. Don't specify template arguments. Let the compiler deduce them. For examples, to transform reduce has 5 template parameters, but none of them are specified when calling it. They are all deduced. Constraints. Use constraints to specify the requirements on template arguments. This function only makes sense for integral types. How can we specify that? Enable if on the return type, or enable if on a dummy template parameter, or a requires clause that checks a type trait or a concept in the template parameter, or a trailing requires clause that checks a type trait or a concept, or a C++20 constrained auto function parameter. This is a template, despite the lack of the template keyword. Writing class templates. Keep it simple. Document the expectations on template parameters, with constraints if possible. Specialization is defining a class that will be used instead of an instantiation. We want safe size of, which returns 0 for types where the size of operator is an error. This by itself isn't enough. A specialization for type void, an empty parameter list, specify the instantiation that this is a specialization for, return 0 instead of using the size of operator. Works for void, but still fails for other incomplete types. We need partial specializations to fix that. Add 2 partial specializations. The first matches unbounded arrays, the second matches function types. This handles most cases, but not all. This is not a good design, so flip things around. The main template handles all the problematic cases. The partial specialization handles all the normal cases. This safe size of works correctly, but it's better written as a variable template than a class template. Class and variable templates can be specialized. Type alias templates and concepts cannot. Function templates are complicated. The type name keyword must precede the qualified name of a type that depends on a template parameter. Example of that on the previous slide. Because C++ declaration syntax is a mess. This can be parsed 3 different ways: as an expression statement, as a variable definition, as a function declaration. If a name depends on a template parameter, the compiler doesn't know how to parse this. Humans know that value type is the type name, so this is a variable definition, but the compiler assumes value type is not a type. The compiler tells us how to fix this. If we do that, it's all good. Writing function templates. Make all template parameters deducible, except when its only use is in the return type. The compiler can't deduce the parent type of a function parameter. This one is pretty obvious. Why not? This one is more subtle, but it's still not deducible. Avoid complicated overload sets. Std vector is an example of what not to do. Avoid function templates that accept everything. This is really bad. It will match more calls than you want it to. Rules for function template specialization are complicated, so ignore them. Don't specialize function templates. Use overloading instead of specialization. Non-template overloads instead of full specialization. Template overloads instead of partial specialization. Wait, what's that? Oh, you're in French. And now you are all template experts.
I'm sorry, that was 6 minutes, so we're going to have to cut the last minute from the... Wow, 127 slides in 6 minutes. Great, 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 great. I wouldn't recommend that to anyone with a fragile heart. Take a breather. Great, thank you very much. Next one, I think, I haven't started it yet. Yes, Andrei. Next one, next up. But yeah, you're doing the right thing, presenting a lightning talk. This is your microphone.
So for every slide of David's, for every 20 of his, I have, I think, 1. Which one's the clicker? This one?
Bottom arrow.
Oh, bottom arrow. Cool. Okay. So I wanted to add to Amir's earlier talk 2 more food guns, basically. We all like those. These are 2 cases that we encountered at my workplace over the last few months. And they're interesting since on the face of it, no one did anything wrong. And yet, disaster ensued. So, I gotta tell you, I love const. And I used to love, until this case, to make data members, to make them const. I mean, what's the worst that can happen? The worst case is that you can't move such an object, so you want it will be ill-formed and you remove those consts. But it turns out that worse things can happen. So in this case, we have class C, a normal class, has some logging on the copy constructor and move constructor. And I have put an instance of it in struct S. Everything is fine. We can see that I am moving an instance of S through the call to function F. And you can see the move constructor being invoked. But as I said, I like doing const. And if anything goes wrong, it will fail to compile, so no problem there. Wait a minute, where are those compilation errors? And what am I seeing down there on the right? It says copy constructor. Oops. So what's going on here? I am indeed moving S. The default move constructor of S is going to attempt to invoke the move constructor of C. Or rather, it would invoke some constructor of C, which, it will get the C instance with the concurrent value category, which now has a const in it, so it will get a const star value, which of course will not bind to the regular move constructor, and it will happily bind to the copy constructor. Now imagine if C was a huge vector, which you were sure you were moving, so that would be our first, whoops. Takeaways as currently expressed in our coding conventions after this incident. We no longer allow const data members unless the containing class is both non-copyable and non-movable. I like to call that non-transferable. I enforce this rule less on primitives where I don't really care if it's a copy or a move. Second case, this is a nice one. So we had a function that needs to return some OS internal, some string contained in some Windows database. So it's some constant memory address, no reason not to just return a const char pointer from there, no issue. And occasionally, if this function doesn't find that resource, it returns an LPTR. Okay, all fine. Then we needed some additional functionality. We needed, depending on some Boolean switch, to sometimes call a second function which needed to build its returned string dynamically and return its std string. And we put those two in a ternary condition. So what happens now if we still call f1 as before? Yep. So when you put something this way in a ternary condition, you get the common type. The common type of a char pointer in the std string is a std string, and you get the std string constructed from a null pointer, which is undefined behavior. Oh yeah, and as in the first case, no one did anything wrong. So here the takeaway is a bit more delicate. I also had a long reflector thread. More or less my condition was that we can do probably with this. Just don't return a const char pointer unless it can never be null PTR.
Thank you. Thank you. It's all right. I'm used to it. It still works. Great. Next up, we have... Anton. I said you were the fifth one. I don't know where I'm at yet, but yeah. Here's your mic. Here's your clicker.
Mic check, mic check. Mic timer. Is that a clicker? Yep. That's a clicker. Okay. Well, hello. I'm Anton Veselskyi from Ubisoft, and my talk is Unconditionally Readable C++. So what's that about? When we write code, we have two goals. First, this code must work. And the second one, it must be readable and easy to interact with. Meaning other people will read, call, use, God forbid, extend or rework your code. And my talk is going to be a compilation of tips for code readability focused on conditions and better conditions to make them descriptive and verbose. It's supposed to be a meme, but the last one kind of looks like C++ contract. So, tip number one, give names to your conditions. I gotta go fast, not as fast as David, but give names to your conditions. So if you have a huge condition, it won't hurt to break it into simple ones and store them into the Boolean variables with clear names. That's the naming part. And then your if statement will read as a plain English sentence. If line is in range and feature is activated, we do something. But the good part is that there is no punishment for doing that. There is no performance cost. If you initialize your bool variable once and then use it once, compiler will just throw it away. And bad and better part will be exactly the same for the compiler. Next tip, don't use negatives. Use positive conditions when possible. Negative stuff is harder for our brain to comprehend. And when you say, if it's not disabled and not expired, it takes quite a bit for your brain to catch up. But if you say, if it's active and valid, you get it instantly.
So let's combine both. Yeah, if you have a statement in parentheses that is negated, you can open it up with De Morgan's theorem, and maybe it will be simpler. So example being, if it's cold or not want ice cream, not, it hurts my brain to think what should happen for this condition to be true. But if I open it up, it's not cold and want ice cream. Better? I guess so. But you can introduce an extra variable, because is cold can mean different stuff for your class or your code base or whatever. But for this specific check, it means is ice cream weather? And there is no downside in introducing extra variable for your if statement to read. If ice cream weather and I want ice cream, I guess I'll get some ice cream. So reads in English as English. Perfect. Next tip. Oh no, I have some proofs that it takes no space. Compiler Explorer sneak peek. No optimization, is ice cream weather, takes space on a stack, there is a move, it's yellow. Some optimization, it's gone. Moving on. Don't bury side effects in your conditions. If you have functions that execute meaningful logic or process data or whatever, move them out of if conditions. Save the result into the variable and check the variable. And you say, Anton, but it doesn't look that bad. But if you have a more complex condition, it might be clear for you where the logical part is and that everything that goes after fetch data may be dependent on its execution. But for people that will work on it after you, it might not be so clear. And then last topic that's kind of Boolean adjacent is toggle parameters for the function. So, look at this function. What the parameter means, I don't know. It's hard to tell. You need to hover, you need to match with the header. And the worst part is if you use this function and you want to say true, false as the last two parameters, but for some reason you say false, true, and your code doesn't work, it's a pain to pinpoint why, because you will debug and you will get this aha moment kind of later. So if you don't have access to the code and you're just a user of the library, the least you can do is to document what parameters mean. But it's kind of bad because it pushes responsibility on you as a user. But if it's your function, there is better stuff you can do. You can introduce an enum to represent each of your Boolean parameters. And even if it has same values as false and true instead of like cached, not cached, whatever, it's still better because it forces the users of your code to verbosely say use cache flag true, which is self-documenting, embedded in design. Is it good? I think it's almost the best. The better would be like that, for it to take 1 byte instead of 4 bytes. Another solution could be the parameter object, where you take all of your Booleans, combine them into one structure, and then you pass this one structure in. You can initialize it with designated initializer syntax from C99 that dropped in C20. So it's self-documenting, kinda. Then you can have default values for your fields, simulating the default values of your function parameters. And the best part is that you can remove the ones that you don't want to customize and set only a few fields that you actually care about. And the last option, last bit, is a bit mask. So you can combine it all into one bit mask, set it, and check the bits instead of checking separate bools. And as with the case where we just had separate enums, it's self-documenting, because with OR, you actually verbosely say what do you want to set, and the stuff that you don't want to set is going to be false. There are also that neat syntax from C++20 where you say using enum, and then you don't need to repeat the long enum name each time. Thank you.
Great. Thank you. Oh, thank you. My clicker. Thank you, Anton. Do we have time for more? We do have time for more. I'm thinking we have. Oh yeah, it's Leo. Leo, next one. We're on the internet now. Ooh, so it might crash or it might fail. Ooh. Slideshow. Yay. Yeah, this is your microphone. This is your clicker. Yes.
And this is working. Amazing. So, hello everyone. So, my name is Leo. I'm an engineer for Woven by Toyota in Tokyo, Japan. And today I'll try to talk about template hell, sorting type list, and other funny stuff. So, a while back I started to write a SI unit support library. So I was bored. I wanted to practice variadic templates, so it was a good way to learn. And come on, it's just a simple library. It's going to be easy, right? And so I set a goal for myself. So I wanted to support only sensible unit operations. So you can add meters with meters, but you cannot add them to seconds. But if you multiply meter and meter, you get meter squared. Easy. And I wanted to make things even easier for myself, built-in string representation, and everything at compile time. I had a lot of fun. So first thing first, we need to define what's a unit, what's a value. So in my case, I decided that a unit would be a symbol, like meter, second, kilogram, whatever. A priority that's useful for sorting later, and a power, like so I can have meter squared, second minus 1, and so on. And the value is an ordered list of units and a double. So for example, if I want a speed, I have a value of meter 1, second minus 1. And yeah, so we want an ordered list of units. So at some point, we need to sort that type list, like we need to sort that tuple. And so that's what I did. So I built sorting stuff to sort generic type list. I used a lot of variadic template metaprogramming, a lot of type traits, a lot of recursions. It was ugly, you can see it. Very ugly. Like a simple sorting function took me 200 lines of code with a boilerplate. It's not that much, right? 200 lines. I'm sure like many of you have like billion lines projects, but just for a sorting function, it's a bit much. It's hard to read and it's harder to maintain. But it worked. Like I could have all my goals were reached. I could have my nice operation. I could have my nice display. I was happy, so I stopped there. It was done. Until yesterday. Yesterday, after talking with people, I asked myself those questions like, can I build it again? Can I build it better? So I started to rebuild it, like finished 1 AM last night, and with new principles. I wanted my code to be better this time. So instead of going for generic type lists and everything, I will make more assumptions that should give me less boilerplates. And type traits are fine, but no, I'm going to use more constext, more consteval, so I can write normal C++. And the way I would work for that is I would instantiate tuples, so I can work with values, do my sorting, do my manipulation in this space, and when I'm done, I can use decal type to go back to types, and voila. And after a bit of work, yeah, this is my new sort function. I just have to call std sort. It's amazing. So that's just for you. And where I had 200 lines of code for the sorting function before, now I have, I think, 150 for the whole library. I'm an happy man. So that's nice, that's fun, but what did I learn? So the first thing is keep it simple. Like, make assumptions, you don't need to build the most generic code ever. Making simple things is going to be simpler, more maintainable, it's easier. The second thing is like constext and consteval are your friends. They are great, use them. And maybe also turn back, look behind and learn from your past self. That first library is 2 years old. And going back yesterday, I think I learned more about programming and templates than in the past year. And maybe finally, my most important key element is don't play with sorting types. It's not worth it. Thank you very much.
Wow. Thank you very much. very much. This is going so well. You're also very good, very well prepared. Thank you for that. Next, I think we have Amir. Did I see Amir? Oh, he's back there. Slideshow. Nice picture.
Yeah, thank you.
Your microphone and your clicker.
Thank you. Hi. I'm Amir. I teach. And the challenge today with students is AI. Back then, Jordan Software, Joel Spolsky, the co-founder of Stack Overflow, but he wrote some blog posts before. Have you read about the perils of Java schools? So a professor here, a lazy student, and say to him, in my day we had to program with ones and zeros, you lazy boy. And another older professor comes by and say, you had ones, lucky bastard, all we got was zeros. So today we have 1 and zeros, but we don't have to write them. We have AI. And that's an issue because recent trends, and this is not an empirical study, it's observations, maybe anecdotal, but I stand for that. Things are getting done faster. Students are doing quite well, but code quality is not necessarily better. Students struggle to answer questions about their code. I mean, something is working. Oh, how did you do that? Let me see. Let's sit together. And they cannot find in code simple stuff. Submitted code relies on materials not taught in class. Well, you know, they didn't write it. Students tend not to read compiler errors or debug their code because it is much easier to copy it into the chat. And students submit working assignments but fail to reproduce the same or similar code during exams. So these are the observations, let's say, in the last year or so. Not so good. Using external code. Back then, I'm old enough that I was copying lines of code from a book. If you're younger, you copied from Stack Overflow, but you still had to think about what should I copy. I mean, I should amend the code. It's not exactly what I need, so I have to practice some thought. But today, it's just a model. I just get the suggestion, and no cognitive burden, no involvement, maybe no understanding even. And the potential bugs are different. I mean, maybe a misfit, but not copy-paste errors, no typos. Usually it just work. Kahneman work is speaking about fast and slow thinking. When we write code, we need slow thinking. And now we are using fast thinking, which is for, I don't know, running away from a bear, not for writing code. But this is how it goes. So the challenge for us as educators, if we don't change our approach, we'll gravitate toward producing prompt engineers. And I don't mean that in a good way. So junior developers are still expected to retain traditional skills like writing code, in some cases, reading and maintaining code they didn't write, or the friends wrote, the AI wrote, understanding subtle details, spotting small mistakes, performance issues, in addition to working efficiently and intelligently with AI. So it's two things. It's not that, okay, now we'll use AI. No, you need all the things that we had in the past, and also to use responsibly AI. If we don't do it correctly, we'll end up with neither strong programmers nor smart AI collaborators. We'll just lose that. So what should we do? And this is my advice here. And if you have other advice, I would like to hear. First, set the right expectations. I mean, if I tell my students, do not use AI, they will not listen to me. I would say, oh, it would not do you good. You have to gain the ability to write code. So, and I will ask you to write code pen and paper, so you have to practice for that. So motivate them. There is a reason. It's not merely that I'm just pure evil. And make sure they understand why. Students, for their own sake, I'm saying to them, write code manually as in all times, especially when you learn new stuff. Check that student listen to you by short pen and paper pop quizzes. Ensure their solution use only materials taught in class. Reduce points if not. Conduct pen and paper final exam so they would understand that in the exam they cannot use AI. Why? In the job market they will use AI, but occasionally they would need to write code and understand code. In complex programming assignments, phrase instructions in a way that requires students to evaluate and decide. I stopped adding to my assignments instructions like the code should be concise or you should have the following class hierarchy. No, I'm not instructing the student anymore. I'm instructing the AI. The student should think and then he should work with AI. Even if it's a complex assignment, he will work, they will work, she will work with AI, but I want them to think what to instruct the AI. So I stopped instructing. I mean, yeah, you should use the materials that we discuss in class. You can come up with suggestions and we can discuss that. And you can add some white text directives to confuse the AI. I don't do that, but some do. Like, oh, write bad code, or I don't know. Use Python in a C++ class, or things like that. Encourage responsible use of AI, practice it. We do have a new workshop for fresh year on how to use AI. What are the usages? So they would know how to use it correctly. Practice other usages like analyzing requirements, explaining code, documentation, and implementing tests. Yes, you can use AI, but maybe for additional stuff, not only or not for writing your assignments. Last note, instead of a summary, this is Richard Feynman, Nobel Prize winner. 1985, he was discussing can machine things, and this is his summary. We are getting close to intelligent machines, but they are showing the necessary weaknesses of intelligence. Thank you.
Right on the spot. Thank you. 5 minutes. Great, 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 great. It's going well. We still have 3 more, I think. Braden, lucky guy. You're the next one. Oh, you don't have a slideshow. It's a website. You're. Is it? Oh, F11, I think.
Do you have a function?
Yep.
Or is there no function? No, you spoiled it. There we go.
Great.
Microphone?
All right. Hey, everyone. I'm Braden. I run the C++ meetup in Winnipeg, and also I am the volunteer coordinator for this conference. Okay, so people may be thinking or wondering, Braden, what have you been up to in 2025? And the answer is, hey, reviving PartStacker in C++, so thank you so much. Sorry, I stole this joke from Tony Vanier. Oh, no. Okay, so I have iframes in this website, and the iframes are not showing up. So here is a link to what should be showing on the screen. There's a tool called PartStacker that was written by a person named Tom van der Zanden, who is, as far as I know, a PhD in mathematics, maybe a professor in the Netherlands. And he is very good at stacking algorithms or bin packing algorithms in 3D, and he did that specifically for... Oh, wait. Wrong ones? Oh, no.
It's your website. I tried it, and that's what it gave me.
Is that all I have? Oh, I don't know the buttons. Sorry. Not my clicker. Okay, here's an iframe that does work. The reason why this was made was for selective laser sintering 3D printing. I'm part of this niche online community that uses 3D printing for a specific reason. I'll get into it in a second. If anyone doesn't know about this kind of 3D printing, you're going to learn right now. Basically, the machine, they're very, very, very expensive and harmful to your health, actually. You lay down a layer of powder, and then a laser comes by and fuses it together, and then another layer of powder goes down and that kind of stuff. I use it specifically for puzzles. So I like 3D printed puzzles. I make these. These are all my designs. They're not renders, they're photos. Yeah, that's where my logo comes from at the bottom right. So I like this kind of stuff. They're kind of like Rubik's Cubes, but there's a whole community of us that make this kind of stuff. And 3D printing in SLS is very expensive, but it is very precise, and we want to use it, and we want to get down our costs for 3D printing. That is all to say, there's a lot of backstory to this. This is all backstory. There's no C++ in this talk. Here's the current version of PartStacker as it is today. There should have been a screenshot in the iframe that was supposed to be there. This is what it looks like today. So I packed like, what is that, 10 tetrahedra, 12 maybe, into a bounding box, and there's like a mesh around it. It's not as tight as it could be because the stack settings needed to be changed, but whatever. This was my demonstration here. This is PartStacker Community Edition version 0.3. Let me tell you how I got to Community Edition version 0.3. Basically, okay, so this talk is, I'm just going to talk about how I compiled old XNA code, recovering lost features, rewriting it in C++, and the current work that I'm doing. It'll all be pretty quick. A little bit of backstory that I did miss. This is what I've been doing for the past 6 months. I emailed Tom van der Zanden, or I had a friend of mine who knows Tom van der Zanden send him an email saying, hey, can I use the code, or can Braden use the code, upload it to a GitHub repo, and like revive this project? It was written in 2011 through 2013 in XNA. Does anyone not know what XNA is? Wow. Okay, cool. Okay, so it's a .NET video game development made, it was discontinued actually. Sorry, I'll get to there in a sec. Like graphics libraries, matrix transformations, discontinued before I was born in January 2013. So it's quite a while ago. Now the issue is that like, that I tried to compile this old code. I took this old C# code, like how am I going to compile it? There are some community implementations of XNA, monogame, FNA, neither of them worked until they both did. I didn't get it right the first time. But the problem is there's some deprecated APIs. So like C#'s binary formatter serialization functions just are entirely deprecated now. But I'm looking at 12-year-old C# code, so I just commented that stuff out. I recovered some old lost features though, because the thing is, there's a screenshot that you should have seen at the beginning that showed there's no like mesh box around these packed meshes. I'm using mesh in two senses in the same sentence. Sorry, there's like a gridded box. That was not there in the version that you can download from his website. Where did it go? I have no idea, but I do have a friend who has a version of the software that still has it from the old, when it was put out for some reason, and then it was removed from another version of the software. And so he decompiled it. Oh. That's a laser pointer. He, I have no idea what happened, but he decompiled it. He sent me the decompiled C#. I matched it up line by line to the real code I had. I manually re-implemented the feature. That was fun. And then I rewrote it in C++. Okay, so I used WX widgets, which I already have familiarity with. I actually really like WX widgets. I used the GL canvas, which I'd never used before. I learned how to write shaders and transformations. I unfixed the UI widgets that were previously fixed in place, so I could do like resizing and dynamic resizing and matrix transformations of the graphics. I modularized the code to 6 CMake targets, so I can again modularize that kind of stuff. It compiles on Mac now with GitHub Actions because I don't own a Mac, at least not personally. And you can go to GitHub and you can actually download it, and it's like 5 megabytes, which is crazy because the old Windows one was like 100 megabytes and you had to install it. So now it's a portable executable. You can just download it. If you have a Mac, you can download this too, if you want to use this. So the current work is that recently I've done some saving and comparing of results. Previously, if you wanted to stack something, tweak the settings and try it again, you had to like delete the stack you had before, and if it took like 5 minutes, well, that's 5 minutes of work wasted. Now you can save and compare them. I'm using VC package instead of pure submodules because I'm, getting with the times. And then current work, I want to optimize the packing algorithm, and I want to save and load an entire workspace to a file, which I need a JSON library for, which is why I got VC package. And I want to implement the other feature requests that my 5 users who I all know personally want. Yeah, if anyone wants to know more about this, please go to the GitHub. This is obviously not what I do for work. This is just what I've been doing for fun for the past 6 months, other than these conference talks. Yeah, please talk to me about this. Puzzles and 3D printing and this kind of stuff is one of my passions in life, and this is just a really cool way to merge my passion of C++ with my passion of 3D printing and puzzles. So I wasn't timing myself. Hope I didn't take too long. Thank you all so much.
Wow. And you said that yesterday that you hated sleep. Now I understand why you hate sleep and you want to do more of that. How could you do all of this in 6 months? Wow. Botond, yay, you're next up. Hey, we'll be good right on time. Your microphone and your clicker, it's the bottom arrow.
All right, good evening, everyone. This is my second time at CppNorth. Last year I gave a talk about ClangD, which is my favorite tool for C++ development. And today I'm going to talk about my other favorite tool for C++ development, which is RR, which stands for Record and Replay. And it's basically a debugger that gives you superpowers. So as the name suggests, RR allows you to record the execution of an application you'd like to debug. You do that by running RR record, followed by the command to run your application. And then replay that recording, which allows you to debug it using a debugger interface similar to a command line debugger interface you might be familiar with, like GDB. Also supports LLDB these days, if that's more your thing. There are two important characteristics of these recording and replaying processes. The first is that they're low overhead. Running an application under RR record, the overhead of that compared to running it not under RR record for a typical application is maybe like 1.5x. Most often you don't even notice. And similarly, replaying is fast. The other important characteristic is that it's deterministic. You can, after you have a recording, you can replay it over and over again, and you will get the exact same behavior down to variables having the same memory addresses and that sort of thing. And that means that if you, let's say you're debugging an intermittent issue, once you've caught that in a recording, you don't have to catch it, trigger it again. You can just replay that recording until you've figured out the problem. And so, in fact, if this is everything that RR gave you, just this ability would already make it worthwhile to use it over something like GDB. But it gets better, because now we get to the superpowers. So when you're debugging, you're usually starting from some bad effect, like a crash or a bad outburst, something like that, and you want to track it back to its cause, which occurs sometime earlier, hopefully. Your starting point when you're debugging is usually from the effect. So maybe you've broken at the time the program is crashed. But the cause is earlier, and very inconveniently, conventional debuggers only let you step and or continue program execution in the forward direction. Wouldn't it be great if they could do this backwards? And that's exactly what RR allows you to do. You can set a breakpoint sometime earlier and run the reverse continue command, and RR will execute your program in reverse and get you back to the state where that earlier breakpoint was hit. And it can do this because it has a recording of the entire execution of your program. But more importantly, it can do this fairly efficiently, such that you're not sitting around tearing your hair out waiting for that breakpoint to be hit, usually. Okay, now, what if, to consider another example, you have a state variable and you have some code where a particular operation, like go in this case, requires you to be in a particular state, such as the ready state. And the area you're debugging is you're not in that state. And let's suppose that there are many places in your program that mutate your state, such that if you were to try to apply the strategy from the previous slide where you set a breakpoint, you'd have to set a lot of breakpoints. It's kind of inconvenient. Thankfully, there's something better you can do. You can combine reverse execution with a debugger feature called hardware watch points, where you set a watch point on the location of your state variable, and then reverse continue, and RR will execute your program in reverse until the most recent time that memory location was modified, whatever may have done that modification. So essentially, this combination of features implements an operation that's kind of like, where did my bad value come from? And you can imagine chaining this operation a few times to trace back a user-visible problem down to its root cause fairly efficiently, certainly a lot more efficiently than you might be able to do with a conventional debugger. Okay, so I've already covered some of the strengths of RR, low overhead determinism. Some others are that it supports the recording the execution of multi-process applications, multi-threaded and multi-process, by recording an entire process tree and their interactions. It is also entirely open source. It does have some limitations. The implementation relies heavily on sort of the kernel interface, and so as a result, it's currently Linux only. It also has some requirements on the processor that you're running on because it uses some processor-specific features. I think basically any modern x86 processor should work. ARM support is more recent, so might be more limited there. And the implementation strategy does mean that the overhead gets higher for highly parallel workflows because the recording basically works by pinning your application's execution to a single thread. Okay, this is my last slide. If you want more information, check out rrproject.org. That has links to download and to the GitHub and so on. If you're interested in how it works, there's a very interesting technical paper called Engineering Recorder and Replay for Deployability that you can search for. But you don't have to understand how it works to use it. You can just use it, it's great. I've shown command line usage. There are also GUI editor integrations like the Midas plugin that integrates into Visual Studio Code. And finally, there are some exciting next generation tools being built on top of RR, like Pernosco. I don't have time to talk about it, but check out pernos.co if you are intrigued. Thank you.
Thank you. Good job, good job, good job. I think we have one last one before the laptop swatch. The laptop swap. Andrei, Lei. Oh, thank you. No, that's probably your last slide. Oh, you have a lot of slides. You promised me you're going to do that around 5 minutes? Maybe. We'll see. Okay. So I'll leave you stage. Here's your microphone. Here's your clicker. The bottom one. Yep. Thank
you. Enemies slain. Well, so that was actually my passion project from 2017 when I was still in high school. So this is the map. It's basically just 6 clicks I wanted to automate. So first one, basically there's a treasure hunter that's supposed to come down from the top. There's no one here. Basically comes maybe once in every 20 times. So gonna go to settings, restart it. Now there's one that has a treasure hunter in the top. We're gonna go and start the wave, get the lightning, boom, and pick up the loot. And that's it. Simple, right? I should just be able to automate that very quickly. So first, well, I used the Windows laptop at home, sorry. There we go, Windows.h. Here's a program. Basically, it just moves the mouse, does a left click. Even more code. This one is to just type a key on the keyboard. And you can just see how quickly it types. Actually, very fast. And then another one, even way too much code. But it's probably easier to see how it works. It just looks at a pixel, and then as soon as you see the color changes or matches the RGB that you want, it just gets it. All right, so now let's just revisit the problem with these new macros in hand. So first, I'm just going to put a pixel detection at the top, nothing detected. So again, settings, click the restart. Now this time, it detects something, so I can use a keyboard shortcut, like the letter A, for instance, to trigger that wave to come. Select that spell, lightning, and then just after 10 seconds, I'll just strike the middle of the path. Hopefully I get most of them. Pick up the loot. Great, that's it. So then, lo and behold, but this time I'm smart. Of course, missed. So that's what happened. Evaded to the edges, and then also sometimes the 10 seconds wasn't that great. It would be too early, it would be too late. I miss a lot of them. Not that great. So what do I do? So I thought for some time, and I remembered oh, in the bank they have those vaults in those movies, all the lasers and all that. So what I did is I just basically put 5 lasers, 5 pixel detectors, and on the edges as well. Hopefully it would grab it, and it did. Also, I just realized I tunnel vision into like putting the lightning, which is really small. So I just used a really big blizzard. And you can just kind of see, I should have not restarted it so many times, but you can see basically the next one. Yep. Basically it just works like that. The treasure hunter will come down. Boom. Pick up the loot. And that's basically it. So now I have a 24/7 running automation. But I just thought like, okay, it runs 24/7, but I looked at my school schedule and I thought, hey, I got this spare. I want to play early in the morning, but I can only log in on one device at a time. So once I log into that spare, afterwards I won't be farming after that spare. The whole day is gone. So how can I tell my computer at home to actually like stop this program so that I can play at school and then restart later? Email it. So I just sent an email to myself. It looks for those white pixels of the new email coming in. And then it would read it. And then when I was done playing in the spare, I'd send another email. It would detect the white pixel of the new email coming in, mark it as read. And then it would close out the old stale one, open up Chrome. Nice thing about Chrome is you got the previously used one. You can easily just click it there. And then, well, you can guess what's behind that black box. I'll say this game is marketed towards teenage men. Okay, so I'd X out of all these ads, and then access the map through a quest. You can see at the bottom very slightly there's a little arrow. So it's just going to click through the menus and arrive back at my level. And great. Basically, the cycle just starts again. And when I came back home, more gold for me. So just to put some numbers, in about the 8 hours that I went to sleep and went to school, did the spare, I'd wake up with $30 of gold in my account. But, of course, you know, my parents, they weren't so happy. They'd see the computer crunching, the screen was off. They'd say, Andrew, you're doing something freaky on the computer? And I thought, don't touch it. No. And also, of course, during the day, on peak electricity. That sucks. A lot of electricity for them. But wait, there was a massive development that really changed everything. 1 month later, the game shut down. End of it. So just some tips quickly. First of all, sometimes when you like want to open a program like Chrome or something, what I found is sometimes when you program and then you click it for the first time, it just opens up really quickly. But then every once in a while, yeah, it will take a while to open up. So basically, now my screen, let's say, is all black. I can just basically look for a white pixel anywhere. And then then I know my Chrome is open and I can keep going from there. The second one is for like when you're a human using the computer, usually you click stuff around and that's fine. But sometimes they have like little buffers or delays that like prevent you from like clicking, and then like basically, as you saw in the demonstration earlier, in like microseconds, like trying to click something else, sometimes it doesn't like that. The third one, if you're trying to do like banking or something and you say, let me automate my finances, well, don't use it for that, please. And the last one you saw with the typing, yeah, you can type very fast, but if you're applying for a job and they say, we want to see that you have so much words per minute, yeah, don't do that. All right, that's it. Thank you.
Thank you very much. Did I forget anyone that sent me slides today? Did I? No? So yeah, the real last one is Tom with his own laptop. So we'll see how that works. Can you hold it on? Or do you want me to hold it on for the whole thing? And you have sound also. Yeah. So you need the sound one. Okay. So start with the video. Yeah, I think. What could possibly go wrong? Yeah, what could possibly go wrong? Nothing, right? This is short. Do you want me to hold it? Do you trust me to hold it? Yeah, it's going to stay open while if you go. Can I put one on top Absolutely. Of yours? Okay, and then the audio thing. Is this your audio cable or your power cable? This is your power cable. The audio is probably the other way around. Thank you. Oh, it takes a little bit of time. Okay. Yep. That's good. What's your shared screen? Yay, it works. Thank you. Microphone. Microphone.
Hi. So, teaching the NES. I teach. You can read my stuff there. Teaching C++ is hard. You heard Amir talk about it, but I found a way. They have books how to learn C++ in 21 days. So it involves doing a decade of C++, a decade of physics, a decade of biochemistry. Use the biochemistry to make yourself younger, go back in time, and kill yourself 21 days after you started the thing. That's not a great solution. So from where I work, we went to find a smart guy to talk to a conference, not this one, to another one. There's plenty of smart people here as well, but this one was closer. So we found a guy. We bonded over beer and beards. And he came to our school to teach. It was very nice. I noticed when he was teaching about C++, which he did for 3 hours, we had a 1-hour talk planned, he showed a lot of these hardware schematics. And the ones he showed, they reminded me of the one on the right. Yeah, on the right. Right. Some of you are old-timers. Does that hardware schematic remind you of something? You recognize which one it is? Yeah, the 6502. The old classic, it's wonderful. And I was talking to Guy Davidson and asking him, you know, we old-timers, we had it easy. We worked on these low-level machines. We had to understand that. We had no choice. But these new kids, right, they have all these black box machines and shiny. What do I do? His solution was very simple. Right? He's a programmer. Take away this shiny stuff. Yeah, that's cool. I was playing with that idea for a bit, and yeah, the Commodore 64, that's great. That's great. We all think it's great. It's fantastic. But my students won't find that fantastic, right? The 6502, that's great. So I need something with the 6502 that the students like. You know what? NES. They will like the NES. So I went to my boss and talked to him. I want to do an elective. I don't want to make it too popular the first year because I'm trying this out. He said, okay, make a slide to show the students. So I make the crappiest slide I could think of to chase as many of them away as I could. Oh, okay. So this is the slide I used. Just this, right? In the hope of chasing them away, but that backfired spectacularly. Why the NES? Because it's great, right? It's the first real console. It has a CPU, a GPU called the PPU, RAM, VRAM. It's simple enough to be understood because that was the point, right? And just the 6 ECTS course, it has a modern controller. What? Why is it modern? Because you have movement on the left, action on the right, meta things in the middle, just like we still do, right? All stole that from Nintendo. Well, that's a light gun and an arcade stick, and actually the games are still considered to be fun, so that was my plan. We're gonna do stuff with that. Also, I had just bought this book. Yeah, I have a book buying problem. But I have a book about this, so I'm gonna solve that soon. The NES is actually easy to understand if you understand this schematic, but I won't go through it. You understand the NES, so it's feasible. Also, the students bitch a lot about C++ and the type system. So I told them, look, you can do assembly now. You don't have types anymore. It's everything, right? You have this 8-bit value. You want it to be a pointer? It's a pointer. You want it to be text? It's text. You want it to be graphics? It's graphics, right? So the C++ compiler will not defend you anymore. If it did anything, at least it convinced them that the C++ compiler is their friend and useful. I don't have a lot of time, so I'll just show you some results. This group of students created a version of Flappy Bird, which is 4-player. They had to use the 4-score, which is a janky piece of hardware. They got it to work. They wrote their own music. They stole the artwork from Super Mario. But it's great, a great project. These two students made something they call NESPad, which is actually a version of Notepad that runs on the NES. By the way, they had to present this on real hardware. They did their final presentation using their own tool. They created pages instead of PowerPoint slides, so awesome. The early signs are positive, and if you're a mathematician, please go away. I don't want to talk about R-squareds and relevant data, right? It's the first year I teach this. The students for Programming 4, which is a course in the semester after this one, the average was 8 out of 20. For my students who took the elective, it's 11 out of 20. So that's way better. Now, if I'm really honest, if I exclude the guys who didn't participate, right, I'm still 10% improvement. Of course, that's a self-selection effect, and I had a crappy slide to try and chase them away. But the signs look great. This is, don't you all have to read this? Some of my students have a Discord, and they don't know I'm also on there. Well, they have forgotten, right? So then they write about software to each other, and I highlight what I find impressive. Without retro console, this guy is writing his own tiny OS, right? Without retro console programming, I wouldn't have understood it. I was super happy with this. I also like that he wrote retro with a little accent on it. It's very French like that. So my conclusion is, teaching low-level code on simple hardware builds better modern C++ developers. I teach C++ by not teaching C++. I need your help. If you have any ideas, suggestion, if you're an interesting speaker and cheap because we're a public institution, talk to me. If you have any NES-related hardware, send it to me. If you happen to have one of those on the top, yes, that's a version of the NES. It's a Thai Famicom clone with a built-in keyboard and a built-in CRT. This is, I don't want one of those, I need it. I need this in my life. So if you have one, please provide me one. Thank you, that's it.
Thank you very much. Just close it down maybe for the closing remarks. Will it close the... Yeah. Thank you for being here, everyone. It's all the time we had for the lightning talks, unfortunately. Please be there tomorrow. If you want to prepare a lightning talk for next year's, I'll probably be there bugging you to prepare one. So if you already have one in advance, it's going to be great. Have a great night, everyone.